Hi everyone, welcome back to another video. Let's take a look at this circuit question. Study the circuit below. The battery has an EMF of 12 volts with negligible internal resistance. So we have a parallel branch here. So these are actually in parallel. And then they are also in parallel with this. So let's look at the way that the current is going to split. So if we start, current will go through here, and of course they will close the switch. So then current will go through here, and current will go through here. Now at that point, the current is going to split. So I'm going to use green to represent this top branch here. And then let's use this brown orange color. So it's going to split here. But once it reaches this point, it's going to split again. So I'll use purple for one branch. And then I'm going to use yellow for the next one. Afterwards, it's going to join back up here to this orange-brown color. And it's going to join the green branch. And then it's going to go back to the battery with the full current that it had at the start. So you can see that there's a parallel branch in a parallel branch. Okay, let's look at the question. So it says switch S is closed, 11.2.1, write down the potential difference across the 4 ohm resistor. So for 1 mark, no calculations are necessary most of the time. Here it's just testing to see if we remember the voltage or potential difference in parallel is the same, will be equal, right? And so this battery is giving out 12 volts, right? There's 12 volts coming out from the battery. That 12 volts is not being split anywhere else. We don't have any resistors here. We don't have any resistors here. Nothing of that sort. And so what it means then is that this whole parallel combination here is going to be using up 12 volts. And because it's in parallel, every branch in that parallel combination is going to be using up 12 volts as well. So this here will be 12 volts. This here will be 12 volts. And this entire green branch right here is going to be 12 volts. So every branch in that parallel combination is going to be using up 12 volts. So the answer to the question is, write down the potential difference across the 4 ohm resistor. It's going to be 12 volts. 11.2.2, calculate the reading on the ammeter. Okay, so what is the ammeter reading? That ammeter, that brown-orange color, the ammeter is reading the current in that section, right? So what we can do is we can work out the current that's in the yellow section and then work out the current that's in the purple section. And if we add it together, we're going to get the current in that brown section or orange section. And that's going to give me the current that's in A, or going through the ammeter, because it was split. Now, how do we work out the current? So if you look at the 4 ohm resistor, right? So let's focus on that 4 ohm resistor. What do we know? Well, we know the resistance is 4. We know the voltage is 12. And so we can use Ohm's law and work at I. I is equal to V over R. So voltage is 12, resistance is 4, and so that's 3 amperes. So in this branch right here, that's 3 amperes. Now let's do the same thing, but for the purple branch. So for the purple branch, which is the 16 ohm resistor, we're going to say the resistance is 16. We know the voltage is 12 because it's in parallel. And so we can say that I is equal to V over R again, 12 divided by 16, which is 0.75 amperes. So here, that's 0.75. So at this point, if we want to work out the current here, all we need to do is add it. So 3 plus 0.75, and that's 3.75 amperes. So let's write it out. So the reading on ammeter A is going to be 3 plus 0.75, which is 3.75 amperes. Okay, Next question says, calculate the energy dissipated in the 12 ohm resistor in 2 minutes. So they are asking for energy, which is W. So 11.2.3, they're asking for W. Now what equations do we know for W? So W is equal to V squared over R times T. W is also equal to I squared times R times T. And we also know W is equal to V times I times T. Now let's take a look at the information that we know. So they are talking about the 12 ohm resistor. So we know R is 12. They're also talking about 2 minutes. So time is equal to 2 times 60. Remember, it needs to be in seconds. So that's 120 seconds. Now, looking at the equations that we have, we know R and we know T. So I'm not going to use the third equation, right? And now we have an option. We can either use V squared over R times T, or we can use I squared RT. Now, it's completely up to, it's our decision now, though I want to use the first one. So to use the first one, we need to use the correct voltage value. Because remember, they are asking for the energy dissipated by the 12 ohm resistor. Now, you would be tempted to say that the voltage for the 12 ohm resistor is going to be 12. But that's going to be incorrect. It's not going to be 12. The entire green branch is using up 12. So the 8 ohm resistor is going to use up some of the 12. And then the 12 ohm resistor is going to use up the balance of the 12. So it's being split in a ratio. And so we can work out what each one is going to use. So basically what we want to do is we want to divide 12 volts in the ratio 12 to 8. 12 ohm to 8 ohm. Now how do we do this? So step number 1, you add up the 2. So 12 plus 8 is 20. Then since we want the 12 ohm resistor, we're going to say 12 over 20 times 12. And that's going to give me 7.2 volts. So the 12 ohm resistor is actually using up 7.2 volts. Now that we know the voltage, we know the resistance, we know the time, we can calculate the work. So we're going to use the equation W equals V squared over R times T. V is 7.2 squared divided by 12 times 120. And that gives us an answer of 518.4 joules. That's it. Thanks so much for watching. Don't forget to like, share, and subscribe. I'll see you in the next video. Bye-bye.